Let's take a look at this example. This time we're supposed to design dual input balance output amplifier with the current mirror bias circuit, right? And we're supposed to meet the following specifications. So this is my differential amplifier with the current mirror bias circuit. Okay, I'm supposed to find the values of resistor R1, R2 and resistance R3. And this time we're supposed to design the circuit which is going to have maximum output voltage swing 5 volts peak to peak. Okay, so where are you supposed to start? You're supposed to start from finding the value of resistor R3. Okay, so what we're supposed to do first? We're supposed to realize that current IE1 and IE2 is equal 3.5 milliamps. Okay, so I'm going to say that my IC3, the current which will go through the collector of transistor Q3 is my IC3 is nothing else just the sum of the currents IE1 and IE2. So this is IE1 plus IE2, and this is equal 3.5 milliamps plus 3.5 milliamps. So IC3 is equal 7 milliamps. Okay. Next, we're supposed to remember the formula from problem number 12, where we derive the formula, right, for the current IR3. And the formula looks like this: IR3 is equal IC3, open parenthesis, 1 plus 2 over beta DC. Okay, so IC3 is equal 7 milliamps over here, times open parenthesis plus 1 plus 2 over beta DC. Okay, beta is given in the problem is equal 200. So I have 200, close parenthesis. So I have IR3 is equal 7 exponent 3 negative times open parenthesis 1 plus 2 divided by 200. This is equal 7.07 milliamps. 7.07 milliamps. So this is the current which will flow through resistor R3. Next, I'm supposed to find the voltage across resistor R3. Please realize that the voltage across resistor R3 is the voltage at the base of transistor Q3. So, how I can find the voltage B3, which is also equal to VR3? Simply add the voltages VBE plus VEE. Okay, let me just remind you that VCC in our case is equal 18 volts and VEE is equal negative 18 volts. So VB3 is VBE plus VEE. Okay, so this is equal, VBE is equal 0.67 volts, so this is 0.67 volts plus negative 18 volts. So VB3, which is equal VR3, is equal 0.67 minus 18. This is equal negative 17.33 volts. Okay, so this is the voltage across resistor R3. Okay, so we have current which goes through this resistor, we have voltage across this resistor, so we can find the resistance. So I have R3 is equal VR3 over IR3. Okay, so this is equal 17.33 volts divided by IR3 7.07 milliamps. I use the absolute value because resistance cannot be negative. So I have 17.33 divided by 7.07 exponent 3 negative. This is equal 2.45 kilo ohms. Okay, so this is the resistance of resistor R3. Next, we're supposed to find the values of resistor R1 and R2. Okay, we're supposed to assume that the voltage drop across collector resistors R1 and R2 determines the peak-to-peak output voltage swing. Okay, so the expected output voltage swing in the circuit is 5 volts peak to peak. Since the output is differential, the voltage drop across each resistor is 2.5 volts peak to peak. Okay, so the voltage across each resistor is going to be 2.5 volts peak to peak. Or other words, this is going to be equal plus minus 1.25 volts. Okay, so this is nothing else, just my VR1, and this is also equal to VR2. Okay, so we can say, in other words, that VRC is equal nothing else, just what? RC times IC. Okay, so we can say that this is 1.25 volts is equal RC, okay, times IC. I have to find value of RC. In order to find the value of RC, I have to divide both sides of the equation by IC. Okay, and I'm going to obtain that RC is equal 1.25 volts divided by IC. So I have 1.25 volts divided by IC. You have to realize that IE1 is approximately equal to IC1 and IE2 is approximately equal to IC2. That's why I'm going to write over here that this could be IE1 or IE2, right? Either one. So this is 1.25 volts divided by IE1, 3.5 milliamps. So RC is equal 1.25 divided by 3.5 exponent 3 negative is equal 357.14 ohms. So this is 357.14 ohms. Okay, so in the real life you are going to choose probably 360 ohms. So this is my RC. Other words, RC is equal to my R1. This is also equal to R2. So the value of resistors over here I'm supposed to put like 360 ohms and 360 ohms, okay, because this is the closest value of the resistor, which is going to be equivalent, I can say, to 357.14 ohms. Okay, so we found the value of resistor R3, values of resistor R1 and R2, so we can say that the problem is solved.